Okay, good morning. It's Monday morning. It is March the 30th, and we are still doing chapter 22, enolates. And we're doing the chemistry, the reactions of enolates. Okay. I set my timer for about 20 minutes. Sure, I would love to have 10, 15-minute videos, but I'm not really sure how to cover the information you need. So you can just stop it after 10 minutes and then come back and do it again. So we finished, a lot of people have sent in their POGIL exercises. I have given feedback to those POGIL exercises, the additional problems. Let me just go over a few of the additional problems here because they're important and I want you to make sure you understand them. Okay, so one of the phenol, and then the enol of the phenol would be this compound here. Now, some people drew too many hydrogens, okay? I mean, too many bonds to carbon. So this is the keto, and this is the enol, and that's why it's called a phenol, okay? And this is more stable. So how does that actually tautomerize? That's the word. And when you tautomerize, you have equilibrium arrows. It's actually, I do it this way, but it's not right. Okay, so it's really an intramolecular, like in water. And what happens is this hydrogen here um, goes here, right? And so way I do it sometimes, just because I don't want to go through 6 steps, is I take this double bond here and I say this double bond goes and gets up that hydrogen, okay, and that there's your 2 electrons there, and then I say these electrons go here, okay, and that's how I do my really quick and easy tautomerization mechanism. Some people did it, obviously they looked it up, which was really good. In fact, it'll be easier for me just to show you with the next one. Let's see, because it asks for the mechanism for the acetone and an acid, and then it asks for this mechanism. So this hydrogen here, we get always the carbonyl protonates. That's always the first step when a carbonyl is an acid, okay? And so there's your positive, okay? And then what happens is we have these hydrogens here. Now you have water, and this is a catalyst, so it wants to go back. So the water will take a hydrogen and make H2OH, right? And then those electrons here go here, which is this, and then these electrons go here. Okay, so then you have 1, 2, now you have 1, 2, 3, 4. So you see how it's an intermolecular mechanism where you have some water and acid protonating, deprotonating. But I like just to do it like this to show that the hydrogen goes over here and then that double bond forms the new carbonyl. Okay, the other one, so this is all 23A. We worked on that one. Nobody had any issues there. I will go over number 14. We had a lot of questions on 14. This is one of the reactions you need to know. Okay, so this is alpha substitution. And you use LDA as your base for, you want quantitative enolate formation. So this is your LDA, that's your base. Remember I told you there's about 4 bases to use. And when you do alpha substitution, that means we're going to substitute on the alpha carbon. This is your alpha carbon. This is your alpha carbon. We're going to substitute there. Right now we currently have 2 hydrogens there. That pKa, if you look at that, if I look on your chapter, in chapter 22, I'm going to go to page, I'm going to go ahead and mark this page. There's a table, 22.1. It's also in your slides. Table 22.1, page 1184. That pKa value with the diketo is a pKa of 9. Very acidic. Okay, you wouldn't even need a strong base like this. So the first thing you always do is you make your enolate. Okay, so you just redraw this molecule just like it's drawn, and then you draw your enolate. Okay, now you can add, do an SN2 reaction. Okay, but you need to have a primary alkyl halide. It needs to be primary. So you do this, and then you show that product. And there's your CH3. Keep in mind you still have this hydrogen here. It's still a pKa of 9, folks, okay? And you still have LDA, or you could use sodium hydroxide. But usually when you do alpha substitution, you go with LDA. It's going to deprotonate that to make an enolate again. Right, there's our little monkey face. And then this time we're going to react this with ethyl bromide. And that is how you make that product. Okay, that's 23A. Let's look at the Pogel 23B. And then I think you also had a problem that I gave you, an additional problem. Let's do that one. I don't know if I can remember it. I kind of do from just grading folks' papers. A lot of people wanted to see, a lot of people tried to take a hydrogen from this. Okay, so there's your alpha, that's your beta. Notice this alpha has no alpha hydrogens. Okay, this is an aldehyde here. Okay, this is your only compound that has alpha hydrogens. So this is the one you make the enolate. This was a bonus, folks. So you make your enolate, CH2, there's your enolate, and then that's going to do a reaction with this aldehyde. So this is in the presence of sodium hydroxide because this is an aldol condensation and it's a mixed. You understand how to do that now because I've read your notes. So this is your electrophile. Here's your delta positive carbon, and this is your nucleophile. And then when you're drawing this, a lot of people mess up on the drawing. This is what I'm trying to tell you. Just draw your enolate, folks. Okay, just draw it just like that. CH2, right? And then your new bond is this one. So this is your alpha. This becomes your beta. The new carbon, the electrophile, becomes your beta. And when you were drawing your mechanisms, I needed to see this intermediate. Here's this. You draw it just the same, okay? And then you would treat that with a little bit of acidic water or something to get protonated. And then that would be your beta hydroxy, and then count your carbons. So this is alpha, this is beta. So beta hydroxy carbonyl. That's your product, okay? Now, count your carbons. 6, 7. 8, 6, 7, 8 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Always count your carbons. Now, you add a little bit of heat, you still have base here. Folks, you still have an acidic proton on the alpha. So the base can take this hydrogen away, and it actually does this, okay? So, okay, this is an E1CB. So it's going to, it's a unimolecular, so it's going to all happen within itself, and it's a conjugate base. So this is a conjugate base. This makes OH a leaving group. So the driving force is to reform that carbonyl, and then that leaves, and then your product becomes the carbonyl, and then this double bond here goes between the alpha and the beta. Okay, and here's your beta. That's your beta, and that leaves. Okay, that's your leaving group. So there you have it. You have an alpha, beta, unsaturated. Unsaturated means carbon-carbon double bond, carbonyl. Okay, so when you add heat, that is your predominant product for the aldol condensation. And that is a mechanism E1CB. All right, back to your problems on 23B. Let's see what we have here. Okay, these are aldol condensations. Oh, okay. So one of the things that I said you needed to do, so we're doing additional problems, 23B, page 277. The additional problems, you have to label these. So if you did not label them, you lost a point. Okay, so we're doing retro synthetic analysis. And you're going to have to do this. You have your Quizam 4 on this chapter, April the 8th. Okay, it should be a Wednesday. So the new exam and quiz days are Wednesdays, folks, okay? So look at Wednesdays. Keep Wednesdays. If you're not taking some kind of quiz or Quizam in April and Wednesday, you should worry because you're missing something. All right, so you find your carbonyl. Find the carbonyl and then locate your alpha and beta and draw a line through alpha and beta. So here's your carbonyl, alpha, beta, there's your line, okay? And then so we're going to redraw that, phenyl, and this OH becomes a carbonyl, okay? So there's your beta, and then this one, you just draw the alpha, which is your enolate, you just draw it the same. You see there's no difference. This, no difference in that. And then when you draw your mechanism, you just make your enolate from your alpha. So you just redraw it and then you make your monkey face on the alpha. Okay, and then that's what's going to go after your beta. And then you draw, once again, just draw your enolate the same way. Okay, and then locate your alpha, and then that's going to be your new bond. So that becomes your beta. In this case, I wanted to see those electrons turn up there. And then you draw that and the phenyl. Okay, and then you can protonate it there to make your beta hydroxycarbonyl. Same way with the other. We have our carbonyl, OH. All right, so once again, locate the carbonyl, assign alpha and beta, draw a line through it. There you go. And then your beta, that OH, becomes the carbonyl. All right, so there you go. Now, where is your alpha? This is going to be your alpha. The alpha is here, so that's going to be your enolate. So when you're drawing your mechanism, just make that your enolate. And then it's going to attack your carbonyl, which is going to be your beta. And then you can draw that mechanism. Those electrons go up, and then you get, so there's your alpha, and there's your beta. Protonation. Okay, the other one. All right, locate your carbonyl. Here's your carbonyl. Assign your alpha and beta. Draw your line. And then you redraw. You redraw the alpha. See on this line? You redraw that alpha just like that. That's going to be your enolate. Okay, and then this one here, you make that beta your carbonyl. And you can see that's a self-condensation. Okay, the other one, nobody had a problem with 12A. Let's look at 12B. 12B caused some problems, and a lot of it's because you didn't do the alpha beta, and if you didn't do it, I took off anywhere from a half to a 1. Okay, so you had to redraw that. This is you find your carbonyl, you find your alpha beta. This is an alpha beta unsaturated ketone. Whenever you see an alpha beta unsaturated ketone, you better think I made it by an aldol condensation. Now, at the end of this week, you're going to be doing a Michael reaction. And the Michael reaction, the starting material is the alpha beta unsaturated ketone. So you're going to learn how to make them and then use how to react them. So once again, you sign your alpha beta and you draw your line. Now you just draw it the same way. A lot of people wanted to make, so the beta here is a ketone, okay? A lot of people wanted to disconnect this altogether. Can't do that, okay? The only disconnection is where you made the alpha beta. So this would be alpha. You see that's an alpha? That's an alpha. So this is an intramolecular aldol reaction. So when you add sodium hydroxide, the alpha becomes your enolate. And your beta is your carbonyl. And so this can come here. And you get an in the hydroxy. And then with heat, you get that. All right, so there's 18 minutes of going over your POGO exercises. I do think it's important, though. I will spend a few minutes introducing you to the next one. Page We're doing 23C. This is your last POGO activity, folks, for your whole book, okay? So let's do it, 280. Today I will give you a bonus question. Actually, we won't worry. Yeah, I'll give you a bonus question to work that you can add. And once again, I only want just your weekly POGL. So I really appreciated that on Thursday where people just sent one file. If you can get it to one file, that would be excellent because I have to download, upload, and then re-upload, okay? So sometimes it takes hours just to do that. So it's so much easier to do that with one file than if someone sends me 4 files. If you send me 4 files, that's like 4 different people's assignments that I have to download, upload, download, and re-upload, okay? So if you can do that, I would appreciate that. Okay, so let's do the Claisian because you had the Claisian, and then so we're just going to do Model 1, the Claisian. Okay, so in Model 1, you see you have an ester. So the starting material of a Claisian is an ester. So the aldol starting material was either an aldehyde or a ketone. Okay, the Claysian is an ester. And so because you have esters and you don't want trans, you want to avoid two reactions. You want to avoid saponification reactions, and you want to avoid transesterification. Okay, transesterification is if I used sodium ethoxide. Okay, and all of a sudden I would convert some of my ester to this ester, the ethyl ester. Okay, and this is the methyl ester. So I cannot use this base. Okay, that's why it matters. You want to use the sodium methoxide or sodium alkoxide NaOR, or you want this R to match whatever ester you have here. Remember I said the hardest thing is putting these together, but also figuring out what base to use. You don't want to use sodium hydroxide. That's what you use for the aldol. Because if you do that, you're going to convert this starting material into your carboxylic acid. Okay, so we do not want to do that with our starting material. So therefore, in Model 1, the Claysian condensation, you take two of these methyl esters and you're going to use sodium methoxide. And the product here is a Claysian product. And you need to have this on your reaction sheet because it's another reaction you need. And you'll see that the Claysian product and is the, so this is your alpha, your beta. It's called a beta keto ester. Okay, so before the aldol, you got a beta hydroxy carbonyl. And I say carbonyl because it could be a lot of different things, or you add heat and you got an alpha beta unsaturated carbonyl. Okay, but for a Claysian, where you have to, your starting material is esters, okay, you have to do a beta keto. That's the only way to get the keto. This is your keto. Okay. All right, let's see if we can answer some questions for this model, and then we'll call it a day. And it looks like we have a lot of questions. So I tell you what, I'm going to let you all answer those questions, and then we'll start there for tomorrow. Work your problems, okay? Work your problems, folks. I'll talk to you tomorrow.